example 2, use symmetry to graph r equals 1 minus 3 cosine theta. So some tricks that we can learn first is the maximum value. So the maximum r value will come from, in the previous problem was just the number in front. Now that we have 2, you always combine. Ignore the negative for a second. We'll talk about that. But what is 1 plus 3? It is 4. So the maximum is going to be 4. The negative cosine part, since cosine is negative, this just tells you the direction is going to be to the left. This shape is going to go to the left. That's all this is telling us right here. So whatever shape this is going to be, it's to the left. Because it has two numbers, like addition or subtraction 1, anything that has two numbers like that is either going to be a limacon is probably the best way of saying it, and a cardioid. Now, this one's going to be a limacon because the single number is smaller. So what does that mean? There's going to be this inner loop. And one of the things we can say about the inner loop is the inner loop has a max when you take away this number minus this one. So it's 3 minus 1, which is 2. So the inner loop will be 2 towards the maximum. And I'll show you the picture real quick. And there's the picture. And as you're looking at it, you might be thinking, what are all these dots? Well, that's how they graphed it. So how they graph it is they plugged in values. Now, on the previous problem, I talked about finding the maximum value, and we also did zeros. So I'll show you how we do that again. Let's say we wanted to find the zeros here. What you would do is you plug in the 0 to the graph. And so I'd have, for the r, 0 equals 1 minus 3 cosine of theta. We would subtract 1 over. So we have negative 1 equals negative 3 cosine theta. Now I would divide by negative 3. So what did I do there? I subtract 1 just so you're following along. Now what am I doing? I'm dividing by negative 3. And when I do this, I get that positive 1/3 is equal to cosine theta. And so now you would just do an inverse. And so it's cosine inverse of 1/3 equals theta. Now we don't have a real value for that. So in the calculator, we could type this in. And we could just say, what is the inverse cosine of 1/3? And we get this value. So this is in radians. If you wanted it in degrees, we could hit the setting button, go to document settings, choose degree, and make it default. Do it again if you wanted it in degrees. And we would say that this is 70.53 degrees. So the first one would be at theta equals 70.53 degrees if you wanted degrees. And the second, 0, because there's always, this one will have 2, as you can look at it, hits the 0 there and there. The second would be across from it. Now, I want you to think about cosine. This is in the first quadrant, which means cosine's positive in the first quadrant. So we get a 0 over here. If you don't know, this is 0, this is 90 degrees. 70 is somewhere over here. To get the other one, cosine, since it's x, is also positive in the fourth quadrant. It would come from this angle. So how would you get this one? Well, instead of going up 70 degrees, we go down 70 degrees. Well, going down, you're moving down from 360. So what I'll do to find that exact value is I'll just simply say 360 minus this number there means it's 289.47. That would be my other value. 289.47 degrees. Those are my two zeros. So that, if you want to know where those spots were, would be those two thetas. Now let's go back up here. How will we use these values is you just simply plug them in. If I know the maximum is 4, I'm going to say that 4 equals 1 minus 3 cosine theta. So we would subtract 1, and then we'd have 3 equals negative 3 cosine theta. I would divide by negative 3. And once I do this, I now know that negative 1 equals cosine theta. I take the inverse, cosine inverse of negative 1 is going to equal theta. That means where is the x-axis negative 1? So on a unit circle, if we had that up, on a unit circle, just do a big circle right here. everything's 1 unit. I want the x to be at -1. Here's the x-axis. So it's this point there, which happens at pi. So the maximum occurs at pi. Now again, that's what we saw in this picture. That's what that point is. That's the maximum. How did you get that r value? Well, you plugged in pi there. All of these, they just plugged in other points. That's how they graph that. And I'll find this one real quick as well. Where did this point right there come from? Is it pi? No, pi gave us this one. So where did we get that one? Let's plug in 2. If we plugged in 2, so that 2 equals 1 minus 3 cosine of theta. I would subtract the 1 for sake of time. I'm just going to write 1 equals -3 cos theta. Now what do? You divide by that -3. And so we now have, you know what, one thing. This 2, I just realized what's happening. They're going to count this as a -2 on the radius. So this is a -2 because it's going inward instead of outward. If this is a -2 when we subtract 1, this is actually going to be a -3. Otherwise, we're going to struggle getting this value. So now when I divide by -3, what's going to happen is I get 1 equals cosine of theta, or you're going to ask yourself, where is cosine inverse of 1 equal to theta? So cosine of 1 means you go right. It's the spot over here, which is 0. So if you plug in here, theta equals 0, that's where you get this point. So this one's at theta equals 0. And since I use degrees, I'll be consistent. This one was theta equals pi, which would be theta equals 180 degrees. That's where we get these values. Now, if you want to go from scratch, you don't even have to do any of this. You could just plug in values. I would recommend using values in the hand trick because it'll simplify easier. But so like maybe start from the hand. We've already got a 0 here. So maybe start the next one, finger, which is your ring finger, which would be 30 degrees. Plug in at 30 degrees, see what you get. And as you go around, that's where you'll get these values. So they started here. I bet you this is probably 30 degrees. This is 45, 60. I'm just guessing now. So you would just go around like that, getting all your values. Now you have one for you to try. Actually, one other thing I forgot to include is the symmetry here, because it's cosine, it's going to be polar axis, and you can look at it and see that it's cut on the polar axis. We would include that as well. So this symmetry, it's symmetrical with the polar axis because it's cosine. So that's something to include.